good? Yeah. Good morning, we're group 4 and we're presenting lab 3. My name is Jeff Charles.
And I'm Yusuf.
My name is Mario Duran, and in this lab 3 we will be using a microwave muscle sensor with an Arduino board to measure and display muscle activity. When we move our muscle, our body sends like tiny electrical signals which the sensor picks up and converts into data. Our goal for this lab is to create a system that detects different levels of muscle contraction, strong, weak, and at rest, and uses LED lights to indicate each level. By placing the sensor on a muscle such as the forearm, we can see how muscle activity changes when we flex or relax.
Let's get started.
So basically, let me just explain really quick the placement of the whole circuitry. So we have the Arduino, who is basically feeding 5 volt and ground to the breadboard. And then we have the LED lights basically connected to the ground and to the 5 volts wire basically to the Arduino. And then we have the microwave, as you can see, as my friend Joseph is actually having in his arm, his bicep actually. So we have it connected to the 5 volts that's being fitted for the breadboard, and then the ground, and on top of that we also have another wire that is connected, which is this gray wire, to the analog pin A0.
And so what we have here is to represent 3 different colors that we're going to further discuss into the code. But for the green color, we have it showing at rest. Our yellow color is going to represent intermediate, and then red is going to represent strong values, and we'll be discussing those values upon the code up ahead.
So, like we were discussing before, we're going to have a rest, a weak contraction, and a strong contraction. So what these are the values of voltage. So at 0 voltage, we should be at rest. At 1 volt would be a weak contraction, and above 1.5 volts is a strong contraction. Right here we have our connections between the LEDs and the pins on the Arduino. D4 is for the rest LED, which is the green one. D3 is for the weak contraction LED, which is the yellow one. And D2 is for the strong contraction LED, which is our red one. And of course, we already have our vectors for our voltage and time setup. And we already have our graph here set up with our time in seconds, voltage on the y-axis, and our titles. So what we do is that we run a while loop for 60 seconds, and what it does is that it records the voltage from A0, which is the microwave. What it does is that it compares that voltage that we collect to the strong value. So if it's above the 2 that we set up for if it's above the voltage that we set up for our strong value, then the red LED should light up, but the green and yellow LED should be off. Now, if it's above the threshold value for the weak voltage LED, if it's above the threshold value for the weak voltage contraction, but it's below the strong one, then our yellow LED will light up, but our red and green LEDs will be off. And then, of course, at rest, if it's above 0, but of course below our weak contraction voltage and below our strong contraction voltage, then the green LED should be on, but the yellow and red LEDs will be completely off. And if it's below 0 at any point, if it's collecting below 0 volts at any point, then all our LEDs would be off. And then right here, we collect our data right here, and then we plot it right here.
Now we're going to demonstrate the green LED being lit up when the muscle is at rest, the yellow LED lighting up in correspondence to a weak muscle contraction, and the red LED lighting up when there's a strong contraction. And in the upcoming clip, it's not as noticeable, but the yellow LED is on during the minimal contraction.
We're at rest, intermediate, strong.
So after getting the results, as you can see right here, we're in rest right over here, as it's showing the graph. We're first at rest, then my teammate we kind of got some power in him, so he kind of added a little bit, he was able to control his force, and we get a medium strength, like a weak grip or weak contraction, which ended up in the yellow LED light turning on. And then he got some power right here, and we got all the way to the top with around 4.5 something, which made the LED red light to turn on. Then he kind of was looking for some protein right here, so he was kind of resting because he put so much power on this one that he was like, "Ooh, no, bro, I'm really tired at this point. But then, boom, he turned into Hulk and got the red LED light on like once again. And yeah, this is awesome because we actually got a pretty accurate reading, as you can see on the videos and in the graph as well. So thank you so much for watching.
And this is a more clearer, better image of our code. And if there's any questions that you guys may have, we'd be more than happy to answer them. And thank you so much for watching.